Hello everyone. In this video we are exploring hardware software code design through a practical real-world example by building a real-time clock counter on the DE1 SoC FPGA. Now let's open the quarters. So over here let's open the project. Go to File, Open Project. So this project was given by us Altera in order to get hands-on experience on how to design hardware and software code design. So this is how the manual looks like. DE1 SoC, my first HPS FPGA by Altera. Let's jump straight into the implementation. Now let's open the QSS. Open. This is a platform designer where we're going to assign the peripherals in order to communicate to the 7-segment display. This is how it looks like. Over here you have to go to the IP, then press PIO. This is a peripheral which we will be using to control the 7-segment display or even LEDs. So over here I will be using 7-bit data. The output port value will be 000. Then let me press finish. So if you come down, this is where it's gonna create is first peripheral parallel IO. We have to connect the clock and reset. Similarly, I will be doing this for the next 7-segment display. Since on our board there are 6 7-segment display, we will be using 6 different parallel IOs with 7-bit data width. Over here, as you can see, I defined PI 0, 1, 2, 3, 4, 5. So this makes 6 parallel IOs, which is equivalent to 6 7-segment displays. Once you have created it, I will show you what is the bit width. This is 7-bit width. You have to make sure you connect the S1 to the H2F XI master. You have to connect all the parallel IOs to the H2F XI master of the S1 of their respective IOs. Once you do that, you have to make sure you give the base address and end address. I've given my base address for the first 7-segment display as 01, as 10, 20, 30, and the end address. And you have to make sure that you have to highlight the external connection. Once you've done this, just select generate HDL, generate HDL. After the HDL is generated, you need to go to the top module, and if you scroll down, you have to instantiate all those modules. Over here I have instantiated all the 0, 1, 2, 3, 4, 5, 6, and I have defined the EXA 0 wires over here in order to communicate with the 7-segment display. Now let's compile this part. Now let's move to the software part. This is a C program which I wrote for the 7-segment display. Over here I will be including the header file because we need to make sure the C program can get to know the address of the each 7-segment display. If you come down, this is how the C program looks like, where the count starts at 0 and it goes till 23 hours 59 minutes 59 seconds. This is C code. Now since we will be dumping it, we will be using the Linux, we need to get the executable file of a C program. In order to do that, we will be running this in the embed command shell. Since I have done it already, over here you can see that there is a executable file which has been generated. I'll be copying this into the pen drive, and this is the header file. Over here you can see that I have defined the address and the data width of all the parallel IOs. As you can see, it is for ones, tens, minutes, ones, minutes, tens, hours, ones, hours, tens. We will be using this header file to get the executable C code. This is our Linux. Now let's try to dump the executable file. Connection looks like I've connected the power supply, VGA cable. This is a pen drive where we will be dumping the executable file. This is the connect to the keyboard, and this is connected to the laptop to program the board. The compilation is done, and DE1, the Linux setup is ready. Now let's first dump the C file. And then now let's program the FPGA board. Once you do this, the time counter will gonna start. Now it's programmed successfully. See, the counter is started. This is the seconds, this is the minutes, and this is the hour. So we're able to do it successfully, and the counter is started. Let's meet after 5 minutes and let's see where the counter will be. And this is how you will execute the hardware software code design. And this is the real time counter. Let's meet after 5 minutes. Thank you. This is after 5 minutes. As you can see that I've kept the clock on from past 1 hour 41 minutes. It's 14 seconds. See, this is the seconds, minutes, and 1 hour. Thank you.